Okay. Greetings to you all, wherever you might be in the world. We are happy to have you among us for this webinar that will be hosted by Professor Fassil KEBEDE, a full professor of soil science and a program lead of the Center for Soil and Fertilizer Research in Africa, known by its acronym CESFRA, at the Mohammed VI Polytechnic University in Ben Guerir, Morocco. Professor Fassil has obtained his Doctor of Science degree in soil science from the Department of Soil Science and Geology of the Faculty of Science at Ghent University in Belgium on 16 of September 2002. In addition, he has obtained a postdoctoral position at the same university in 2003 and another postdoc at the School of Natural Resource Management at Bangor University in the United Kingdom in 2007. Professor KEBEDE has more than 25 years teaching, research, and leadership experience, taking up various academic positions such as a lecturer, assistant professor, associate professor, and finishing with a full professor of soil science in the major public universities of Ethiopia, including Haramaya University, Mekelle University, University of Gondar, Jimma University as an invited professor, and Addis Ababa University as an invited professor also. During all these years, he was engaged in teaching courses such as tropical soils, their properties and management, soil fertility and plant nutrition, soil chemistry, managing of salt-affected soils, and soil testing. Furthermore, Professor KEBEDE managed to supervise more than 60 master theses and 10 PhD dissertations, which have been successfully defended to the benefit of the students who were working with him and who have obtained their diplomas. Professor KEBEDE has authored over than 70 articles. Besides that, he has served in different administrative positions, such as an academic dean, an advisor to the Ministry of Agriculture and Natural Resources of Ethiopia, and Director General of the Ethiopian Soil Resource Institute, to worthy mention among others. Today, we are honored that Professor KEBEDE will speak to us about an important topic entitled Status of Problematic Soils in Africa and Management Orientations for Sustainable Uses. The lecture will go, Professor KEBEDE will speak for about 40 minutes, and we'd like to reserve the last 20 minutes for Q&A session, questions from the audience, and answers from our honorable lecturer. Professor Fassil KEBEDE, the floor is yours. And thank you very much for having accepted to inaugurate this webinar series. Okay, now you may share your screen and start your talk.
Is it coming?
Yes. You put full screen.
Okay, I'm trying. Something is wrong with the system. Professor, do you see it?
Yes, Professor Fassil, just go ahead and start talking. It's the presentation.
Okay.
We see it. We see it.
You see it, okay?
Yes.
Thank you so much, Professor.
Put it in the panorama. Put it in the larger. Put it in the panorama. In the large screen.
Yeah, but I couldn't find that. Yeah, just.
It's on the bottom.
Yes, yeah, but it can't go beyond this.
Yeah, you just hire your whole screen. You just grab the red.
Yeah, I have done that. I don't know what.
Okay, well, we'll just go ahead.
Yeah.
At the bottom right, there is that panorama sign that you can click on.
Yeah, I did it, but it's unfortunate. I don't know, it's not working.
Okay, we can see, we can read your slides. No problem.
But I'm not comfortable. Okay. I think.
Yeah, why don't you share your screen again? Maybe something happened. Just redo the whole operation from the beginning. That's good. That's great.
Okay.
You have succeeded.
At last, yeah. Thank you so much, Professor Bulif, for this opportunity. Good afternoon, everyone. Thank you so much for attending this webinar. I am going to talk this afternoon on this topic, as it was mentioned by our Professor Bulif, on the status of problematic soils in Africa and management option for sustainable use. This is one of our ongoing research activities, which is really very critically important and high time probably to be shared among the scientific community, academicians and researchers for the best and sustainable utilization of soil resource in Africa. When I was given this opportunity this afternoon to speak on this topic, I just thought about the objectives of this webinar and have identified 4 objectives. The first one is I would like to very quickly highlight how problematic soils in Africa are severe and complex. The second one is to draw attention about the extreme challenges in use and management of problematic soils. And the third one of the today's webinar objective to point out future considerations for the sustainable use and management of these problematic soils in the African continent. And of course, finally, to use this opportunity to express our interest, our willingness in forging a collaboration with Reform member universities and other institutions on the best use of soil resources of Africa. Today's presentation will include a brief introduction about Africa, which is a kind of an overview, then pedogenic factors pertaining to the soils of Africa. That's also very, very important to understand, because it will be a kind of springboard for sustainable management. Then the other brief point section will be types and sets of problematic soils in Africa, the challenges in use, encountering currently the continent as we try to manage these problematic soils, and of course some valuable future directions that will help to unlock the problematic soils in Africa, and finally some issues on future collaboration with sister institutions in Africa. So very quickly, as you know very well, Africa is the second largest continent after Asia in terms of land masses, and it covers around 30 million square kilometers. It's also speculated that around 72% of the land mass of Africa are problem soils, with, of course, different production constraints. And the third issue, probably as a highlight I'd like to raise here, is really an urgent and concerted action is needed to avoid or reverse worsening land degradation in the face of population growth, unprecedented consumption, and increasingly globalized economic and climate change. So to very briefly highlight about the pedogenic factors pertaining to Africa. Obviously, as you all know, soils are heterogeneous by their very nature, which are composed of the three states: solid, liquid, and gaseous state. In fact, the plasma state as the fourth state can also be included, because we do understand that soils are, again, natural reactors where all kinds of fusion are taking place. So really the plasma state, which is the ionic gases issue, can also be considered as part of really equally important part of the soil. So as you know very well, the nature and properties of soils are heavily impacted by the hydrosphere, biosphere, atmosphere, and lithosphere. The interaction of these all entities will influence, of course, the nature and properties of soils. So if we see those issues very quickly, one by one, for the African continent, the first one is the influence of hydrosphere on the soils of Africa. As you know very well, Africa, the continent, is surrounded by water bodies. If you look at the northern part, where we see, of course, Mediterranean Sea and the Atlantic Oceans. In southern part of Africa, we also see the Atlantic Ocean and the Indian Ocean. Also in the eastern part, still you see Indian Ocean, and of course on the upper part, the Red Sea. So this obviously tells us that there is a tremendous effect of the hydrosphere or the water bodies on the nature and properties of soils, particularly in the coastal part of Africa. And those soil properties, such as the electrolyte, the ionic composition, because as you know very well, all oceans have significant anions, particularly the traditional oceanic cations like sodium and potassium are common, along with the anions, mainly the chloride, of course. So the distribution of those ions can be influenced by the regression and transgression activities of the water body. The particle size distribution, of course, flooding is a frequent phenomenon in the coastal parts of Africa. So obviously, one can expect a change on the textural distribution of the soils. Of course, another equally important soil properties that which can again be affected by the hydrosphere is the redox potential of the soils because of inundation. Obviously, the pores, the capillary pores and non-capillary pores of the soils can be filled with water, and of course, oxygen deficiency can stay a problem, which is unacceptable, as it would be the cause for ethanol production. And the pH of the soil also can be affected by the hydrosphere part. The other equally important factor, again, which influences the nature and properties of the African soils is, of course, the lithosphere. As you know it, in terms of structure and relief features, Africa appears to be different from other continents. You people know very well, lithology describes the mineral composition and structure of geological material, which is based on rock formation. So as we closely investigate the surface lithology of Africa, which is composed of dominantly carbonates, northernmost, particularly the northernmost of Africa, and for this same parent material is also shared by the southern tip of Africa. We saw also sedimentary rocks of different range, igneous rocks of acidic and basic nature, and so on and so forth. So the presence of these different surface lithology, or if you want, paramaterials, obviously do influence the soil profile of Africa. Texture, again, another property, the grain size, which is heavily influenced by the type and nature of paramaterials. The cationic and anionic composition, as usual, the igneous, acidic igneous rock, or maybe basic rock, of course, can be different source for cation and anion. The clay mineral, which is also very, very important, which determines the activity of the soil, the reactivity of the soil, is also hugely impacted by the paramaterial. And finally, the pH. The third equally important factor, which is the biosphere. Biosphere also significantly influences the nature of Africa, as you know, because of the different agroecological zonations. We see the continent with different types of vegetation. As you know, as you can see, the equatorial part dominated by green color, which designates, of course, the forest. There are also bushlands and caves and forest transition and mosaics still around the equatorial or the tropical regions. So then collectively, of course, these all issues will influence the biochemistry of the soils of Africa. The organic carbon content, total nitrogen, humus chemistry, and protein, lipid, polysaccharides, so on and so forth, are really significantly affected. The last but not the least part is the atmosphere, and this is really unique again for Africa, as you know very well, and as you can see from this map, the red one, which crosses the continent just above the equator, we call it the Intertropical Convergence zone, where two different, the basic wind types dominate. Basically, they do start in the places where there is a high pressure, that is in the Tropic of Capricorn South and the Tropic of Cancer and the North. So when they, of course, meet there, obviously they do determine the onset of the rain, not only the onset, the start, but also, of course, the distribution of the rain usually be impacted. So eventually, this will influence the agroecological zones, soil aeration, soil water, soil temperature regime, and so on and so forth. So obviously, the soil properties, along with the other factors, are heavily impacted or modified. So now, having the major pedogenic factors for the formation of African soils, this afternoon I would like to very quickly highlight the types and status of problematic soils in Africa. For example, as you can see, this gentleman plows his wetland, and it's really very difficult for him to plow because it's extremely wet, it's waterlogged, and as you measure, of course, the redox potential, we can have a negative value here. There is no oxygen, but doesn't mean that this land is not suitable, but it's only suitable for limited crops such as paddy rice. But anyway, it's really one of the problematic soil types. So to be very well comfortable, let's define together the term problematic soil as a working term for this afternoon. So problem soils or problematic soils are those soils can be defined as soils with inherent physical or chemical constraints to agricultural production. I like the term inherent. It's not something a man-induced problem, but it's a natural one. So in that case, we have to learn to live with it. In this case, our responsibility would be really systematic utilization of these soils. Otherwise, if these soils want to be properly managed or inadequately managed, obviously they will be hugely degraded to the point they reach irreversible. As a result, of course, the land itself, as it was mentioned by Dent, may go out of production. So I tried to review critically, and there is one map, as you can see it from the slide, which tries to depict the distribution of problematic soils in Africa. Of course, depending upon the agroecological zones. So the first one, as you can see from the map, is the desert soils. These soils, basically, you see them both in the Sahara, northern part of the continent, and the Kalahari Desert in southernmost of Africa. So the dominant soil types of this region are the calcium soils and gypsy soils. I'll come back later on. But it is speculated that desert soils do account for. I'm referring particularly to calcium soils and gypsy soils to represent 6.5. Which is really very, very, very high because, as I have already mentioned earlier, the culturally important landmass of Africa is around 2.9 million hectares. So 6.5 of that is really a huge number. The other type we do see is the saline or sodic soils. Basically, the solonchaks and solontes, and we do find them in the coastal region of Africa across, and because of improper irrigation activities, irrigation soil salinity and solidity still could be a problem. So as stands today, though there is also the misleading data, but around 2.3% of the continent is categorized under this problem. The other one, the sandy soils, particularly referring to the areno soils, soils, which are the sandy soils, and the rego soils. These two together do form 24.5, which is a huge number. We would find all over Africa, regardless the agroecological zone. The other ones are the acid soils. In this case, acid soils can be differentiated into two based on their location. The first ones, those soils that are located on tropical land, in this case, the feral soils and the acrid soils, the two combined form 13.2%. And the other acid soils, normally those soils that we see in the highlands and the tropical highlands, particularly the niche soils and also the undersoils. Undersoils also, they do originate from volcanic eruption. Basically, they have an acid pH, so they can still be considered as acid soils, but they have also their own problem. Dark clay soils here does refer to the birch soils, and around 3.4% of Africa is really a birch soil dominated environment. And as you know very well, these soils are really very tough soils. If someone is not really very intelligent in utilizing them, they are very tough in influencing, of course, the time window, because they get swelled when they are wet, and then they become as hard as stone when they dry, and that is really a kind of cyclic event. So it really poses traction. It influences, of course, workability, but it can also be seen really one of the potentially acceptable cultural soils. The other one, the ferruginous tropical soils, again, are considered as problematic soils. These are weathered soils, aged soils of the continent, and in this group we do find the lixivious soils and partly cambi soils. So cambi soils can also be found in different parts of Africa. The poorly drained soils, particularly the clay soils and the fluvial soils, are still significant in size. They are around 4.4%. And finally, the shallow soils, which are, of course, the liptosoils. We can see them again throughout the continent, and their number is really very, very high. It's around 70.5%. So, having that, I would like to very quickly highlight some of the major problems, not for all, but for some of the soils, problematic soils that we see in Africa. Now, if we see now the two soils here, the calc soils and gypsy soils, they are really soils of the arid land environment, where there is a huge amount of calcium and bicarbonate for the calc soils, and of course, high amount of calcium and sulfate for the gypsy soils. And the pH is high, obviously, for these two soils. Soil drought is again another problem, because you find them in the xeric environment. The amount of organic carbon is very, very significant, I must say. Of course, low nitrogen content, and P, the level of P is also very, very small for two reasons. Number one, the source, and number two, because of fixation with the divalent cations, calcium that we see. Then the P becomes occluded, as you know very well. The other problem, the low content of zinc, copper, manganese, of course, and iron. But when you see the other side, which is the molybdenum, very, very high. And if irrigated, these soils can have a great potential to support growth and development. In this case, barley, cotton, forage crops can be grown very well. The other part that we see, the saline and sodic soils, these are those soils that have excessive soluble salts, and the source of those soluble salts can be anything. Anyway, the extent that we see in the particular in the Solon check is really very, very high to interfere with the normal growth and development of plants, unless and otherwise properly managed. And the other part, as you can see, the solensis, which is the other version of the saline soil, sulfuric soils. In this case, when we have exceptionally high amount of exchangeable sodium, as you can see, the columnar structure in the B horizon, of course, will create a trouble. And this sodium, as you know, it is a dispersant by its very nature. So sodium will influence the structural arrangement of the soil. So we can't irrigate the land unless and otherwise we fix the problem. The infiltration problem will remain there for some time and the year. So really, these are the two major problems. Along with that, we have also problems like specific iron toxicity. Only selected or dominant cations such as sodium, calcium, and magnesium are common, along with chloride, boron, sulfate, and others, of course, depending upon their nature. High pH, particularly the pH of the solentis or the sodic soil, can rise as high as like 10.8 or 4, which is really very, very high. That is beyond the permissible pH range for many plants. So really, we have to find means really to neutralize that higher level pH by applying phosphogypsum whatsoever approach. The other major problems, as I have already mentioned, which accounts around 70.7 the African continent, are the arenasols and the rigosols, and we find them everywhere. And as you know very well, the arenasols are dominated by sand particles. They are workable, which is very, very good, but they have very poor nutrient retention capacity, very poor water holding capacity. So special attention is really very, 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 very important. And again, when you examine the microbial activity, is also less active, because, as you know very well, sands are inactive or inert by their very nature. They are quartz coated at some point, so it's really very, very tough. But these soils are really very potential soils for trees, as long as they are properly managed. Maybe the last, but the least part is acid. Acidity is really one of the encroaching problems, rapidly growing problems in the African continent, particularly in the high rainfall regions. And of course, there are different data about distribution. Some do say 20%, others 25%. But in this way, that way, really, soil acidity is a serious problem. But it becomes serious problem whenever we plan to grow crops that are not acid tolerant. So it's really, we have to be very careful here. But cash crops like coffee Arabica, coffee Robusta, tea, cocoa, cacao, oil palm, other cash crops can be grown very well on this type of soils, as long as the land, these soils are provided with sufficient amount of plant nutrients. Otherwise, these soils really do remain a challenge because of their high level of aluminum, iron, and manganese, which of course we call them aluminum toxicity, iron toxicity, manganese toxicity, and the pH. The pH is very, very low, particularly when the pH falls below 5.5. Obviously, many of the microbial activities are retarded, inhibited. Phosphorus fixation is also another serious problem. And of course, the availability of the micronutrients also are also impacted. Slaking and caking of the structure is also another problem, because these soils are dominated by silt. So it's really a friendly approach is very much required for the sustainable use of these soils. Okay, so based on my experience, I tried to identify some of the challenges in appropriate use and management of problematic soils in our continent in Africa. The first one, there are no sufficient data, reliable data in Africa. Many of the data that uses them are obsolete, or the quality is not also very, very, very good. For example, if you see this map, this is a map depicting about the distribution of soils of Africa, but it's really very, very, very small. You see the western part of Africa, northern and western part of Africa have been mapped at the scale of 1 to 5 million, unlike the northeastern, southern part of Africa, where we have only a 1 to 1 million map. But I think Africa does deserve to have the detailed soil map showing what is located where. The other problem, we don't have still sufficient information on the soils, crops, landscape, and climate, because bringing the different data together will help for sustainable development in the African continent. The other problem which I have identified is, as you know very well, we have different classification systems. The famous ones at global scale, of course, the US taxonomy and the World Reference Base. It's really very, very great to have them. However, there is a problem when it comes to coloration. And the two, for example, as you can see over here, I tried to extract this table to show you how, for example, classification is done according to the soil taxonomy. So we see here T-peak, the haploidals, up to great group level. But for management level, of course, we have to go deeper, at least to family level. But when try to find equivalent nomenclature in the world frame base, for the first one, it is ferric, rhodic, ali source, which is alumic, cutanic, and lumic. But it lacks really coloration. And I think why we do classification, the purpose of soil classification is one. That is really for technology transfer. It's really one of, I know there are multiple advantages, but the primary one, the key one, is really to simplify, to disseminate technologies, soil technologies. So we do lack that. The other point, as you know, there are indigenous soil classification systems in Africa, and unfortunately they are overlooked. So we have to find the means really to put together so that the soils of Africa are very classified and understood for proper management. The other problem which I have already identified, again, the methodology. There are different methodologies known to us. As you can see, one of the methodologies here we see for data interpretation, like for soil pH data interpretation, which is good. But the major problem, for non-soil scientists, acid soils does refer for any soil with a pH less than 7, or to be very critical when it has a pH of lower than 5. So, but there are different soil types who do share similar values. For example, the feral source, as you can see, as I've already presented earlier, the acri soil, the ali source, the lixi source. Although they do share, same denominator in terms of pH, their nature is different, particularly their chemistry. The clay chemistry is different, which influence, of course, the cation or the anion exchange. At the same time, of course, the fate of the fertilizer applied to these soil types, even the ameliorants are totally different. So for example, now this table does tell us very well how the different elements are available, particularly being solubilized. But this cannot be applicable to all, as long as there are so many factors, such as, for example, root temperature, which influences the solubility of elements. Therefore, it's really very, very important to develop site-specific one, or rather problematic soil-specific tools that can help us to properly first understand and then manage. The other same problem, the traditional table that we have, which is more of generalized classification of salt-affected soils, taking into account the EC and ACP. So grossly, we do classify that any soil with an EC of greater than 4 and less than 15, then automatically it is categorized as saline soil. But for any soil with an ACP of greater than 15 and less than 4, then it's automatically classified as acidic soil. But that's not enough, to be honest, because depending upon the source of cations, like these days, lithium can have equal effect as that of sodium on the structure of the soil. The same thing holds true for magnesium. So really, when it comes to money, this can be very good for academic purposes. But when it comes to for remediating purpose, it really poses. So this calls again for revision of the tool when it comes to its application to Africa. The other problem, there is again a failure in linking soil fertility with crop and with crop climate and landscape suitability. For example, subject matter specialists in the area of particular soil science, they can use this triangle to gauge whether a given soil is fertile or not, knowing the distribution of hydrogen, calcium, and sodium. For example, when any soil, which is when the micelle is dominated by hydrogen, then automatically that is classified as an acid soil, and the conclusion, that soil is of course infertile. And the opposite, when the soil is saturated with calcium, which is at about closer to pH 6 or maybe 6.5, or sometimes to neutrality, then this time the soil is said to be fertile. When you see again the other side, again the dominance of sodium, then we can classify as a strongly alkaline soil, which is infertile. So this type of classification alone, without really aligning with the nature of crops, will not take us any more in the future to solve the African problem. So it's really one contribution, but it has to be brought together with other yield determinants or with other factors, so that better understanding achieved. The other part now, the management orientation now that I am proposing when it comes to with the wise use and best use of problematic soils. Of course, the first one is start soil research with pedologic investigation. For different reasons, for the past 30, 40 years, pedology really lost ground. And it's not good, because in Africa, our development is based on soils. So in this case, we have to understand very well the morphology, the physics, chemistry, mineralogy, and hydrological properties of the soils for the best and economic utilization. So I am proposing for any research from now on just to make really pedologic investigation as part and parcel. The other one is design sustainable soil management system for unlocking the potential of problematic soils. They are problematic soils because they are not usable for other crops. But for example, as I have already mentioned, acid soils are not really problematic soils as long as they are used for plantations. In fact, with little amendment. So really designing sustainable soil strategies would be profitable for Africa. Develop practical and precise tools and methods that can help us to really understand very quickly and accurately major problems in Africa. That's open for research. The other proposition, create an African expert panel for soil classification, partnering, of course, with US taxonomy and world reference-based teams. This is really very, very important. The classification systems we have, they are very good, but still missing valuable issues. So it's really high time to have Africa-level expert panel partnering with our great scientists in the US taxonomy and world reference-based team. The other thing is strengthening the working group of FAO who are responsible for harmonization of soil laboratory procedure. And as you know very well, in many African soil laboratories, we use different techniques for measuring nutrients. For example, if you look at the total organic carbon, the traditional one we use, it of course, it is the black and ochre method, which has been developed in 1934, which is a good one, but only does extract around 58% of the carbon content in soil. So we are now, there is again a gradual shift these days to chemistry in anticipating to have an international harmonized system. But still, understanding the biochemistry of the soils of Africa and other factors is really very, very important to develop African-based analytical tools that can help us to really understand the nature and properties of our soils. The other one is develop a joint proposal for sustainable use and management of problematic soils in Africa. I'll come back later to that, but here at UMSP, we are very much opportune, and also looking forward to partnership with other African colleagues for the best use of soil resource. But later I'll come and then say a few additional points on the subject matter. And the other one is training of the next generation soil scientists, particularly at PhD level, would be very, very helpful, who can be the next policymakers, the next champion, who can help Africa to feed itself, and not only feeding but also export surplus produce to be produced in Africa. Okay, now taking this opportunity, I would like to very quickly, for 1 minute, to tell who we are. We are the Center for Soil and Fertilizer Research in Africa at the Mohammed VI Polytechnic University. As you may know, Mohammed VI Polytechnic University is one of the internationally known universities with a special focus on the African continent. The university has a very high instruments, very well equipped laboratories with great scientists, of course, with a great burden and commitment to work, of course, in the continent. So CESFRA is one of its entities. We have identified 3 focused and key strategic areas that will help both the African continent. The first one is pedology and soil use, which deals, of course, with the systematic understanding of soils and eventually mapping. And then after analyzing the suitability of soils, then we do propose, of course, land use plan. So for this purpose, we have state-of-the-art laboratories. The first one is the soil spectroscopy laboratory, and the other one is the soil informatics laboratory. By the way, the soil spectroscopic laboratory, it is a champion, regional champion laboratory for North Africa and Middle East countries. The other equally important entity of the center is soil health. As you know very well, this is really one of the emerging issues, particularly in the advent of climate change. So understanding the wider span of this area, again, will be critically important for the sustainable utilization and management of the African soils. All issues starting from erosion, carbon deterioration, pollution, and acidity, alkalinity, you just name them, are very well addressed in this part. And the third entity is the nutrient science, fertilizer prescription end use entity. And this is a very, very prominent area where our scientists do investigate the biogeochemistry of the nutrients, the traditional nutrients, the 21 that we know today, and also discovering new ones, like understanding very well the contribution of iodine, selenium, vanadium, so on and so forth, and not only really understanding their biogeochemistry, but also work hard on developing customized fertilizer that will help boosting productivity of these soils, along, of course, also developing other saline tools that will be very much instrumental for the rational and wise use of fertilizer. So we have fertilizer formation and testing laboratory. And we're very much happy, particularly to work with our Reform university member universities and other international regional institutions who are interested in doing research in the 3 areas, in pedology, and soil use, soil health, nutrient science, fertilizer prescription, and use. Finally, these are some of the incredible staff members of the center, along with the soil spectroscopic and soil informatic laboratories. With that, thank you so much for your attention and also attending this first webinar. Thank you so much. Professor Boulif, back to you, sir.
Fassil KEBEDE for this very interesting talk about the soils. In fact, the soils in plural or the soil in singular, it's the origin of life. And nothing we can do without soil.
That's right. That's right, Professor.
Yes, for various uses, especially for food production. Thank you very much for the speech about the soil. And I would be happy now to take questions from the audience. And
thank you.
Let me see. There is one question from Ismaila Dion. And the question goes like this: how do you situate organic matter and a reliable alternative for restoring soil health in a long-term basis? You can read the question on your screen, Professor KEBEDE.
Yeah, that's really a very, very, very useful question, particularly at the continent level. As you know very well, deforestation is one of the serious problems in Africa. Not only deforestation, and also overgrazing is an issue where residue crop residues are really lost significantly. So when we collectively do see the level of organic carbon content, it is very, very, very low. So it's really high time to increase the organic carbon content using different approaches. But as you know very well, because of the location, because many of the African land masses are located in the tropical region where insolation is very high. In this case, mineralization would be really a serious activity. So we have to come up with the biomasses, soil biomasses, that can help returning the carbon organic matter content, so that the carbon organic matter content is raised. So it's really very, very important to consider that one, and we can consider it as carbon farming. There are different approaches where you can easily build up the carbon, the soil carbon. Just starting not only forestation, but also all forms of intercropping, crop rotation, screening plants basically that you find them in the tropical environment where they can be grown in a very short time with vigorous biomass. So there are really plenty of options and approach. So that's right. You have really touched the right button. Managing the soil organic carbon means managing the biological property of the soil, managing the chemical property of the soil, and of course, managing the chemical property of the soil. So it is really the centerpiece of soil fertility management. So that's right. That's right. I fully agree with that.
Very good. In relation to this question, there is another remark by Mr. Ali Tiam. He says, great. The Africans must know that it is compulsory for us to start agricultural biology, which means organic farming. So it is related to building the carbon in the soil. Do you have any comments about that?
Yes, that's very good, but the philosophy is different. Organic agriculture is different from the conventional one. So in this case, for example, biomass is the issue. Africa has not sufficient biomass, as I have already mentioned, to really raise the level of carbon to the expectation. Otherwise, as I have already mentioned, increasing the soil organic matter content obviously helps to diversify microorganisms. Basically, they are the workforces in the biogeochemistry of every single nutrient that you find in the soil. So it is unquestionable, really. But there has to be a very clear strategy, and that is why I did say mapping would be really first and foremost issue, probably for better intervention activities. Otherwise, you can't really plan organic agriculture everywhere. There are criteria for introducing that type of eco-friendly practice. But you have to bear in mind that clear criteria should be there, starting from the availability of resources, and that resource, I tell you, in sub-Saharan Africa countries seriously lacking. Otherwise, there is no doubt about the importance of maintaining the soil organic matter content, or really shifting to organic agriculture.
Okay, very good. Well, many of our students and many of our viewers would like to have your slides, and if with your permission, would be happy to share them with anyone who could ask for them.
Yeah, of course, Professor Bouffier, yes.
Yeah.
It's my pleasure to share.
Very good. And the other thing is that I heard you talking about pedology, pedology, and it is sad. I'm sad to hear that pedology has regressed. The teaching of pedology and the discipline also. And how can we revive pedology and interest in pedology in our schools and faculties and universities?
Yeah, thank you so much, Shirley. I think this must be a policy issue because, as you know very well, whether we like it or not, soil is becoming an issue. It's becoming a global issue. It's really a key component for the Sustainable Development Goal and so on and so forth. So every single country these days, particularly in sub-Saharan African countries, do focus on the preparation of soil map, which is really the starting point, because that will help to monitor the nutrient balance and then strategically decide what to do next when it comes to the fertilization of really their soils. You know it very well, Africa has missed the first green revolution. And now it's the turn of Africa to really catch up and benefit at least in second green revolution. And that is why in 2006 in Abuja, where heads of states met together discussing about the future of Africa in using their soils appropriately, particularly by increasing nutrients in it. Of course, they all have pledged to increase the level from the current, from the then, of course, 10 kg usage to a little bit higher, up to 50. But unfortunately, how many African countries have made the pledge is questionable. But anyway, it is really a policy level decision. It's very, very important because soil remains very, very critical in different aspects, even in light of this climate change abatement, so on and so forth. Therefore, it's really high time now for the different governments to invest in the discipline itself, in soil science, in the infrastructure, in the human capacity development. So that time really pedology will get attention, which of course is an instrument to revolutionize production and productivity in Africa. That's right. It is all about policy, Professor Bulif. Otherwise, no one now can be successful overlooking soil science. It's really a base. Around 95% of our food comes really from soils. So it's really very, very pertinent to critically understand the nature and properties of soils in different countries of the continent. I think Africa lagging behind in this regard. So it's now time to return back to give more attention to soil science.
Pedology.
Pedology, yes, pedology, which is the center of soil science, of course.
Okay, thank you very much for stressing the point. We have another question on the screen from Mr. Adnan Ben Yaish, and he says, how can the quality of soil mapping help to reach the sustainable use of soil in Africa?
Well, it is a very, very good question. You know, for me, treating soil is like treating a patient. A patient must visit his doctor or her doctor. And of course, the doctor will prescribe the necessary drugs after prognosis and diagnosis. So in this case, to come up with the best use or with best technologies, one has to be in a position to understand first the types of soils. People these days, they use a shortcut for development. Like, for example, basing on soil properties will not really transform agricultural productivity it can only serve for 1 or 2 years. So my point over here is, at least Africa hasn't had at all a good map depicting the distribution of its soils. So it's really high time now to get that. And of course, the data must be dependable one. And that data eventually will help us really to classify it appropriately and then map the soil types, not the soil properties. There is a big difference between soil property map and soil type map. So I'm now referring to soil type map. For example, now the fairer soils are totally different from the Ali soils or maybe the Akri soils. Why they got that nomenclature? Because they are different in morphology, different in physical properties, chemical properties, biological properties, and so forth, which in one or another influence, again, productivity. Therefore, basing on that, one can come up with really profitable and productive recommendation, really. So that's really very, very important. That's why I'm saying even the maps that we see here and there are maybe good enough for policy making purposes. But as a soil scientist, I can't say they are good enough for management purposes. I think management is the most important aspect. The policy making people, okay, they can understand the severity of the problem. And finally, they can, pump money, a lot of money for development. But for the successful management and use of these soils, I think detailed information is imperative. So that's my point. That is why now I say good attention to the field of pedology must be given, which would be really the base or the foundation for development.
Okay, thank you, Professor KEBEDE. Here is another question on the screen from a friend of UM6P, Dr. Rashid Mosaddaq from INRA in Rabat, Morocco.
Yes, thank you.
He says, nice presentation, Dr. Fassil. And I have a question about fertility depletion in African soil. How to resolve this problem?
Yes, it's really a very pertinent issue, and nutrient depletion is really one of the serious problems. Professor Smalling, a lead professor, has mapped the status of nutrient depletion in the 1990s, and to date, that is, I think, the only map we have really to discuss about the status of nutrient depletion. But I know it's very, very, very severe. Primary nutrients, nitrogen, phosphorus, and potassium, are heavily degraded. You know, the reason is very clear, because erosion is the #1 problem in the African continent, both wind and water erosion. Therefore, the loss is very tremendous. It's very, very, very huge. So really, the right strategy in this case to redress these issues, of course, the systematic use of mineral fertilizers, because plants do need ready-made food. There's no doubt for it. Soil-based, what I call customized fertilizer, will help to ensure productivity. So really, that's one of them. The other one, as I have already mentioned, use of integrated soil fertility management system. I think it's more of, again, holistic one, where again local farmers can make really their land more sustainable, utilizing locally available resources. So there are different avenues really to reach there. But one thing which is very clear is nutrient depletion in the African continent is very, very, very serious. And you know, the population explosion in Africa is very, very serious one. It's now over 1 billion. And it is agriculture which must feed them. And there is a world in modernizing agriculture for feeding. And as you think of modernization, of course, soil is one of the components. And we have already seen that at least around 72% in terms of land mass, you know, the soils of Africa are heavily degraded, severely eroded. There are problematic ones in one or another. So it's really unquestionable to work hard to really address the issue. And then that's why I did mention the issue of the Abuja Declaration. It is not the commitment of heads of states. Now, many of the African heads of states are now committed to fulfill their pledge. It's a matter of life and death. Yeah, it is a naked soil. Soil without nutrient is a naked one. So it's really up to each government in the continent to work hard to find the means to nourish their soils for the betterment of course, their future.
Okay, thank you, Fassil. There is another question about, from Habumu Gisha Ismail, and he is thanking you very much for the presentation. And he says, how can we increase the use of organic fertilizer? And he wants you to tell him the strategy we can use.
Okay, thank you so much. As I have already mentioned, Africa, it is a continent of biodiversity. We have plenty of biodiversity, but unfortunately, all are unused. For example, we have plant species that are very much suitable for nitrogen fixation. So in this case now, first of all, screen promising or potent plants which can be source of biomass. So in this case, the type of the plant can be anything. For example, microalgae. It's really one of the untapped resources in Africa. which can be a very good base or ingredient for composting, for compost preparation. That's number one. And number two, like for example, use of rock phosphate, ground rock phosphate. It's also an organic one. It becomes mineral after treatment. But rock phosphate, a powdered rock phosphate, being, for example, mixed with microalgae and other stuff, can be really the best source of manure or organic fertilizer. Sorry. So there are different options. So it's really a matter of sitting down, writing a proposal, and get things done. Otherwise, with the advent of science and technology, where you can have reactors, biological reactors for composting and other stuff, understanding those or identifying those potent, be it microorganisms or macroorganisms, will be really the good source for promoting organic agriculture or organic farming in Africa.
Thank you. Here is a question from our dear colleague, Professor Leonardus Vergets. He says, "Dear Fassil, nice presentation, thank you." And he says, you talked about a bunch of soil issues, and he is asking the very question, what is the situation of Africa's Soil Science Society? Is it active? How do you see its importance and how to strengthen it? It's a good question.
It is a very good question, Leonardus. As you may remember, during our recent objective setting for the 2021, I just identified as one of the objectives for CESFRA, because the African Soil Science Society, it is an influential continental society where it has from different research and academic institutions. So I have already started communication. So really the African Soil Science Society will be one of the instruments for the systematic understanding of soils, because when the annual or biannual conferences are organized, of course, it has to be organized in such a way that soil profiles of different countries are described by the scientists and reach consensus, and of course every biennial or annual conference should also produce proceedings or technical reports clearly stating about this type of soil. So really current knowledge on soil science can be strengthened as long as we bring the soil sciences of Africa much more closer. So it's really right concept, right idea, Leonardus. Yeah, we're heading to that one, but it's not enough alone. It has to be institutionalized. It has to be really owned by the respective research institutions, ministries of agriculture, and so on and so forth, for the better understanding of their respective soil types.
Yes, I agree with you. And it's the case for all the other scientific fields, plant breeding, plant pathology, agronomy. We must strengthen our scientific societies in the whole, throughout the African continent. Thank you, Aldous, for this interesting question and remark. I will be posting the last question related to what? Yes. to water by Mr. Ali Tiam. Are you the Mr. Ali Tiam that I know? We are happy to have you among us. And the question says, what about the difficulty of water for the land? I think the water, there is no life without water. How important is the water problem in the tropical and subtropical soils?
Well, to be honest, this is also a very, very great question. Thank you so much for asking this question. However, when do you really analyze the probability of rainfall distribution, or even the amount of rainfall, for example, in the tropical Africa? I think I can't say that water is really a deficiency. It's not deficient. But the problem is we don't have water harvesting technologies. I think during the rainy seasons, the plenty of water we receive should be harvested. That's number one. And number two, there has to be also a kind of an in situ soil conservation practices, so in situ moisture conservation practices. We know that evaporation is very, very, very high from the lands of Africa. But still, we can be clever, like by identifying cost-effective systems in not disrupting, but at least reducing the loss of water through evaporation. For example, the use of pumice. Pumice, it is a volcanic rock, crushed once. Basically, they're less inactive. And if we mulch our soils with them, then obviously we can increase the degree and time for retaining water for some time in the year, at least during the growing season. So that's number one. But obviously, in the drier parts, in the semi-arid environment, water matters. But in this case, the fundamental problem is, of course, shortage of rainfall. But doesn't mean that there is no groundwater. There is plenty of groundwater. So in this case, one has to really understand and map the distribution of groundwater. What's located where, and in terms of quality. And for example, here in North Africa, obviously irrigation is done from groundwater sources. So in this case, the point, of course, knowing about the quality can be brackish, or maybe saline, or maybe solid, or maybe high level of boron in some instance, of course, which can pose, of course, deleterious effect. So in this case, there is water, but it's a matter of, again, treating the water. And again, as I have already mentioned, when I was trying to explain about the contribution of hydrosphere to the soils, Africa is surrounded by oceans and seas. It's now time also to start some desalting activities of the ocean water. They are there. And again, of course, there are techniques available in that regard. Even some countries are still really moving forward, like desalting of the ocean water. So I think there are multiple options. So it's and again another issue. For example, fog. Here in Morocco, many places it's really foggy during the winter season. So significant amount of water can be trapped from the fog, can be harvested from the fog. There are techniques of harvesting water from fog. Yeah, I understand. So I can't say that really water is a serious problem, but we have to really have a very clear strategy what to use when, and of course, finally, systematic water utilization by increasing the water use efficiency. In this case, working with our breeders, of course, producing or releasing germplasms, that are efficient in the water use efficiency, will of course will be the future again land race or varieties in the face of climate change. I know I'm not saying I'm not denying water is not a problem, but still the available, we have enough available water from different sources. But what's really important, getting the right strategy for the basis of these meager resources.
Well, I think we are running out of time. Thank you very much, Professor KEBEDE, for this very valuable and important conference about the soils and their importance in Africa. And we have heard you. We must get all the, we must get our interest translated in reality by giving more importance to soil science and pedology and soil management to produce more food for the continent, for our continent. And I think we have heard you. We have heard you today, and many people have heard you, and will be delighted to stimulate and dynamize this African society of soil science. This is very important. Thank you very much again. And we will take this opportunity to communicate about our programs at the School of Agriculture, Fertilization, and Environmental Sciences, and especially about our accredited master in fertilizer science and technology. This master has been accredited since several years, and it's operating right now. And we would like to invite potential candidates who are interested in this master to get in touch with our faculty, or just embark on the platform. If you have an application, if you are a young person willing to join this master, you just load your application on my.um6p.ma. And if you have problems and if you want more information, you can email the ESAFE team at esaf@um6p.ma, or just draft a message on the WhatsApp at the number shown in the screen. And of course, you can all the time visit the ESAFE website at the address mentioned on the screen too. Okay, very good. And I think we have come to the end of this our lecture, our seminar. We will be advertising for the second webinar, which will be given by another authority of EFA, Dr. Akim Doberman, who will be speaking to us about the paradigm of the One Health concept in relation to soil nutrition, plant nutrition, and ending with human nutrition. And I thank you very much. Thank you all for your interest and for being with us for this webinar. And we hope to see you again and welcome you again for the next webinar next week at the same time. So long. إلى اللقاء. Hasta la próxima. Thank you very much.